Hello friends, hope you are well. Today I'm going to introduce a very important concept in probability and statistics, especially in the context of modeling relationship between two variables is called the simple linear regression model. Here we have two variables, let us say x and y. One is can be looked as upon the cause and the other is the effect y. We can call x to be the independent variable and y to be the dependent variable. What we want to do is to have a model so that based on the values of x we can predict the values of y. Now there can be in different ways to model a relationship between two variables, and the simplest of them being to use a straight line to model the relation between the two variables. The idea is that suppose I have got n pairs of values x1 y1 x2 y2 and xn yn on two variables x and y, and then I plot them on an xy plane, which is called a scatter diagram, something that I have explained in the context of correlation. So you know that if you compute the correlation coefficient, then correlation measures the extent to which a straight line is a good fit to the scatter plot, that is the points on the xy plane. If the correlation value is close to +1 or -1, then you know that a straight line, most of the points tend to be close onto a straight line with a positive or a negative slope. Now suppose you compute the correlation coefficient and see that the correlation value is close to +or -1, then you have a good reason to believe that straight line is a good fit to this data, or you can use a linear model to represent the relation between the two variables x and y. So in this case, we have a model which is of the following form, that y you can write as equal to a plus bx plus an epsilon. Now epsilon is the error term. So if you take any pair of values for a and b and plot the straight line a plus bx, and then on that plot you see the points x1 y1 x2 y2 xn yn, then of course not all the points are going to be on that straight line. Now the deviations of the y values from the straight line, that is, or the difference between yi and a plus bxi, that deviation yi may be above the straight line or below the straight line. So this deviation is represented by this epsilon. This is the error component or residual component. So simple linear regression model is of the form y equal to a plus bx plus epsilon, a residual. Now this what makes this model special is, one, you are using a straight line to represent the relation between two variables, and second, that the properties of the residual. So here we, in the simplest form, that is in the simple linear model, we assume that the epsilons or the residual values, they are generated by a normal distribution with mean 0. That is, the expected value of the residual is assumed to be 0. This represents the fact that if a and b are chosen properly, then most of the and the correlation is high, then there will be a straight line for which most of the points will be close to that straight line. That is, some of the points will be on the straight line, some will be above it, some will be below it. Now if you calculate the epsilons for the points that are on the straight line, the residuals will be 0, and for the points which are below the straight line, the residual values would be negative, and the points which are above the fitted straight line, residual values would be positive. So the idea is that for a good fit, when I add the residuals, then they should cancel out each other, and that should be equal to 0. That would be one of the first criteria while choosing the values of a and b. So we say to be A and B will be chosen in such way that the residual values should cancel out each other. So one of the basic assumption is that the residuals have mean 0, and the second important assumption is that they follow normal distribution. So under this and then third, there is an assumption of homoscedasticity. That means we assume that the residuals all have same variance. So we can say that the residuals are IID random variable with mean 0 and following normal distribution. So in a simple linear regression model, the problem is that how do you determine a good fit, that is how do you determine the values A and B, which is the tangent and the slope, tangent or slope, and the constant A in that straight line, such that this straight line is the best fit to the n pairs x1 y2 x2 y2 and x and yn. So this is determined by something called Euler's method, ordinary least square method. Here the idea is that if I take the sum of squares of the residuals, then that is a non-negative number. Obviously I have told you that the sum of the residuals is 0 if A and B are chosen properly. So the first condition is that summation of the residuals is 0, so we cannot do anything about it. But sum of the squares of the residuals is a non-negative number. Now we will choose A and B in such a way such that the sum of the squares of the residuals is minimized. So given n pairs of number x1 y1 x2 y2 x and yn, the problem is to choose A and B in such a way that the summation of yi minus A minus b into xi whole square, where the sum is over all the n pairs, is minimized with respect to the constant A and B. And so that is the main idea. Now how do you determine such A and B? For this I'll give you a hint. So now this sum of squares of residual is a function of two variables, namely A and B. One is the constant, another is the slope B. So now you have to take partial derivatives with respect to A and B and equate them to 0. Then you will get two estimating equations for two unknowns A and B and solve them. So I'll leave it here today. I will suggest that you look up also in Wikipedia for simple linear regression and you try on your own to find the values of A and B. So this is a brief introduction to the concept of simple linear regression model. Basically, what is the idea? That you are having n pairs of points. What is the best fitted straight line?